Let's take a look at some examples. Here I have already written the example. To find the relationship between the zeros and the coefficients, we need to verify this. So here given the question is, find the zeros of the quadratic polynomial x square plus 7x plus 10, and we need to verify the relationship between zeros and coefficients. So first we need to find out the zeros of the quadratic polynomial. Equation is x square plus 7x plus 10. We have to solve it is by a middle term splitting. So product of the two zeros should be 10 and the sum of the two numbers should be 7. So we have to split 7 into two terms. So whose product is 10 and the sum is 7. Those are two numbers are 5 and 2. So we need to write the middle term as x square plus 5x plus 2x plus 10. Now we need to factorize separately. First one, take x common. So in the bracket left with x plus 5 plus, now 2x plus 10 common is 2, left in the bracket x plus 5. Now again x plus 5 is a common factor, so therefore we will write x plus 5 and the left out terms are x plus 2. So now we need to find the zero. These are the factors x plus 5 and x plus 2. Now we need to find out the zeros of these polynomials. For that we need to consider x plus 5 is equal to 0. Find the value of x. X is equal to 5 will go that side, becomes minus 5. And the second one is x plus 2 is equal to 0. So therefore value of x is equal to 2 plus will go that side and becomes minus 2. So we got the two zeros, minus 5 and minus 2. This means one of these value will consider as alpha, that is minus 5, and second value as beta, which is minus 2. Now we need to find out the relation between zeros and coefficients, and we need to verify it. So what is our first relation? Sum of the zeros. Sum of the zero, that is alpha plus beta, is equal to minus b by a. This is we need to verify. For that first we will write down the values of a, b, c. So what is the value of a? Is 1, coefficient of x square, b, coefficient of x, that is plus 7, and c, which is a constant term, that is plus 10. So we will find out the relation alpha and beta. We already got alpha and beta. Alpha is minus 5 plus beta is minus 2. So we will get minus 5 minus 2, which is minus 7. So we got the alpha plus beta value as minus 7. So let's take what we will get the value of minus b by a. Minus of b, minus value of b is 7, value of a is 1. So it is minus 7 by 1, which is also minus 7. This means both the values are same. So we have verified alpha plus beta is equal to minus b by a. Now we have to verify the second relation, that is product of zeros. Product of 0, alpha beta, that is equal to c by a. We need to verify this. First take the product. Product alpha and beta values are minus 5 into minus 2, which is minus minus plus, so it is 10. C value is 10 by a value is 1, so therefore it is 10. So both are equal. So this means that is also we have verified alpha beta is equal to c by a. It is verified. Is that clear? Like this we will take few more examples. So now equation is t square. Second example, t square minus 15. This is a quadratic polynomial because the highest power of t is a variable, highest power is 2, so therefore it is a quadratic polynomial. Now we have to factorize this. So this is t square minus 15. That means it is of the form a square minus b square. So factors of these are a plus b into a minus b. So what are the factors of this then? T square is a square of t. 15 is a square of root 15 whole square. So therefore a is t and b is root 15. So therefore what are the factors? T plus root 15 into t minus root 15. These are the two factors of this polynomial t square minus 15. Now find the zeros. We need to equate each polynomial to 0 and find the value of t, which is minus root 15. T minus root 15 is equal to 0. So therefore value of t is plus root 15. So two values of t we got. That means these are the values of alpha and beta. So alpha is minus root 15 and beta is plus root 15. So we need to verify the zeros. Zeros, relation between the zeros and the coefficients. So those are first is sum, that is alpha plus beta, and the product, which is alpha beta. This is equal to c by a we have to verify, and this is equal to minus b by a, that we need to verify. From the equation, first write down the values of a. A is, equation is t square minus 15. That means coefficient of t square is a, that is 1. B is the coefficient of t. T term is not present, that means b value is 0. And c is the constant term, which is minus 15. So now check the relation. Alpha plus beta minus root 15 plus root 15. So minus root 15 plus root 15 is 0. Minus b value is 0 by 1. So 0 by 1 is 0. So it is 0. So that means our relation is verified. Second, the product of the zeros. Alpha beta. Alpha value is minus root 15 into beta value is plus root 15. So minus 15, root 15 into root 15 is 15 and the sign is negative. C value is minus 15 by 1. So it is equal to minus 15. So both the values are equal. So therefore we have verified this relation also. It's clear? This is our second equation. Now there are a few more examples we need to check out. So third example, few irrational numbers we will consider, the polynomials with irrational coefficients, that is root 3x square plus 10x plus 7 root 3. Now in this, what's the value of a? Coefficient of x square, which is root 3, b coefficient of x, that is 10, and c is equal to constant term, which is 7 root 3. Now first we have to find the values of alpha and beta, that is zeros of the polynomial. So for that we need to factorize this equation. The product of the two numbers, where we have to split the middle term, that is root 3 into 7 into root 3. That means the product needed is 7 root 3 into root 3, which is 7 into 3, 21. And the sum of two numbers is required is 10. So whose product is 21 and the sum is equal to 10. The numbers will be 7 and 3. So write the middle term after splitting. Root 3x square. First number is 7x. Second number is 3x plus 7 root 3. So now we have to factorize them separately. Root 3x square plus 7x, common factor is x. So left terms are root 3x plus 7. Here now 3 and 7 root 3. Common factor is root 3. As we know, 3 written as root 3 into root 3. So root 3 into root 3x plus 7 root 3. We can take root 3 common. So left out is root 3x plus 7. Common factors root 3x plus 7. Left out terms x plus root 3. So these are the two factors. Now find the zeros. Root 3x plus 7 is equal to 0. So therefore root 3x is equal to minus 7. X is equal to minus 7 by 3. Here second one, x plus root 3 is equal to 0. X is equal to minus root 3. So one value of 0. Alpha is minus 7 by root 3 and beta is minus root 3. Now we have to verify the relation. So sum of the zeros, alpha plus beta is equal to minus b by a. A value is, we are right again, a value is root 3, b is equal to 10, c is equal to 7 root 3. So verify, alpha value is minus 7 by root 3 plus minus root 3. So this simplification, minus 7 by root 3 minus root 3 minus 7 minus 3 by root 3, which is minus 10 by root 3. Now what is the value of minus b by a? B is 10, outside minus sign, a value is root 3. So minus b by a is minus 10 by root 3. Alpha plus beta we got minus 10 by root 3. Both are equal, so therefore we have verified this relation. Another one, product of zeros. Alpha beta is equal to c by a. Alpha beta minus 7 by root 3 into minus root 3, that is root 3. Root 3 get cancelled, minus minus plus 7. Then c value is 7 root 3 divided by a value is root 3. So this root 3 cancel, answer is 7. So this is also equal. This means our second relation, that is product of 0, is also verified.